So today we'll be doing current electricity, which is as per CBSE chapter 3. मेरे हिसाब से एक अच्छा चैप्टर जिसको अगर थोड़ा ध्यान से देखें समझें तो यू कैन स्कोर फुल मार्क्स, पूरे मार्क्स आ सकते हैं। जब हम करंट इलेक्ट्रिसिटी की बात करते हैं तो सबसे पहली बात होगी इलेक्ट्रिक करंट की। जब हम इलेक्ट्रिक करंट की बात करते हैं, इट मीन्स ऑल अबाउट इलेक्ट्रिक चार्ज। When charges are in motion, it forms current, and the measurement of this charge is basically the measurement of current, which means I is electric charge flowing per unit time. So I is equal to Q upon T. SI यूनिट हम जानते हैं कि I की SI यूनिट होती है एम्पेयर। Symbol is A. We know current is measured by a device called ammeter, which is always connected in series, so that we can get entire value of current, entire magnitude of current through the circuit. Now, when we talk about current, basically there are two types of current. One is called AC and other one is called DC. When it comes to AC, it means a variable value of current, fluctuating value of current, that we show with the help of diagram like this. If we take I across y-axis and time across x-axis, then this is the variation of something with respect to time is called alternating current. But when it comes to DC, it means the magnitude of charge flowing remains constant with time. Or if you take I even, then there is no variation in it. For DC, we have cell or battery. These are the source of current. But for AC, we know the power plants are the main source. So when it comes to the AC, it can be produced, it can be created in abundance. And that is why in domestic supply, industrial use and other such use, only AC is used or can be used. DC is not that cost effective, and also it cannot be produced like AC is generated. So it has limited use, like we are using torch, remote and etc. in that cells and batteries are used. Now let us come to the electric potential. When we talk about electric potential, like we have a battery, and in battery, what is actually stored? Inside a battery, basically chemical energy is stored. And this chemical energy, where you may find the positive and negatives are marked. This this chemical energy of the battery provides us the electric current. So basically this is conversion of energy, chemical into electric. But in this process, electron or charge is made to move through the negative to positive, and so we take conventional direction of current as positive to negative. So electric potential, basically this battery does some work, and so हम पोटेंशियल को ऐसे डिफाइन करते हैं कि बैटरी ने जो वर्क किया टू ट्रांसफर चार्ज फ्रॉम वन प्लेस टू अनदर इज इलेक्ट्रिक पोटेंशियल. फॉर दैट वी राइट work done per unit charge. Fundamental formula for potential W upon Q. W को हम बोलते हैं work done, Q is charge, and V is potential or electric potential. For that we are using the SI unit, which is volt. Now again we have a device to measure potential difference or voltage, which is called voltmeter. And having said that, the ammeter is connected in series to measure current, but voltmeter is connected in parallel to measure current. Basically, this measure potential difference, not current. So product of current and resistance measures potential difference, and so voltmeter is always connected in parallel. Now there was a physicist named George Simon Ohm. He was able to relate and find a relation, and he found a relation between electric potential and electric current, and that is known as Ohm's law. So let us come to the Ohm's law. When it comes to Ohm's law, the statement goes like: the electric current or magnitude of current flowing through a conductor or cross-sectional of conductor is directly proportional to the applied potential difference at constant temperature. ये कांस्टेंट टेम्परेचर ऐड करना बहुत सिग्निफिकेंट है स्टेटमेंट में, अदरवाइज अपना स्टेटमेंट कंप्लीट नहीं होगा या पूरी तरह से करेक्ट नहीं होगा. Which means Ohm's law is a conditional law. It's not universal law like we have gravitational law or something like that. So mathematically we write V proportional to I, which is V is equal to IR, and thus R comes, and this R is called the resistance. R is called resistance of conductor. Basically, it depends on the nature of conductor as well as temperature. What? Resistance. Depends on two factors: nature of conductor as well as temperature. Nature of conductor means, like copper is the best conductor, so having less resistance or minimum resistance. Aluminum also conductor, but little more resistance than the copper. So nature of conductor means that, and temperature, we'll do it separate. With the rise in temperature, resistance increases, so it reduces. So George Simon Ohm did this, and on the basis of Vi, we plot a graph which is called Vi graph. And because it is proportional, I is proportional to V, so line should be straight, and the slope of the line will give resistance, right? Now he did an experimental arrangement, and it goes like this. उन्होंने एक एक्सपेरिमेंटल सेटअप से इसको प्रूव करने की कोशिश करी, और उसमें उन्होंने कुछ अरेंजमेंट ऐसे बनाई. जिस अरेंजमेंट में क्या क्या है देखते हैं. ये बैटरी एलिमिनेटर है, पॉजिटिव नेगेटिव है. ये हमारी एमीटर है, यहाँ रेजिस्टेंस है. रेजिस्टेंस के साथ में पैरेलल में वोल्ट मीटर लगा देते हैं. ये की है, की क्लोज कर दी, और ये रियोस्टेट है. Then if you plot a graph, this is experimental setup. और VI ग्राफ हम अगर प्लॉट करें तो बेसिकली this slider of this rheostat, if we increase, we'll observe, हम नोटिस करते हैं कि एमीटर और वोल्टमीटर दोनों की रीडिंग चेंज होती है। तो लेट्स से इनिशियली दोनों की 0 है, फिर अगर वोल्टेज हमने 1 करी तो हो सकता है करंट 0.5 आ गई। वोल्टेज अगर हम दोगुनी कर दी हो सकता है करंट भी 1 हो गई। वोल्टेज अगर 4 करते हैं तो हो सकता है ये भी 2 हो गई। If we do it like 3, let's say it is 3. 4, after 4, let's make it 6. And then if we do it 8, then let's say it is coming out to be 4. And so he found that there is direct proportionality between voltage and current. But under that condition, when physical conditions like temperature remains constant. Now, because it has limitations, so we should discuss the failure of Ohm's law or limitations of Ohm's law. तो जब हम limitations की बात करते हैं तो सबसे बेस्ट limitations इनका ये है बताने के लिए कि ये सेमीकंडक्टर में it's not applicable, because when we talk about semiconductor, then we can write like limitations of Ohm's law. Limitations of Ohm's law, that semiconductor does not obey Ohm's law. अगर हम एक ग्राफ प्लॉट करते हैं सेमीकंडक्टर के केस में तो हम देखते हैं कि ग्राफ इज लाइक दिस, which means if it is V, if this is, we need to change this V, we have to take along this side and I along the other side. So semiconductor, right, and I and V, it is like this. तो VI ग्राफ इज नॉट प्रोपोर्शनल, सो तो VI ग्राफ क्योंकि डायरेक्टली प्रोपोर्शनल नहीं है, इसलिए सेमीकंडक्टर के केस में हम कहते हैं कि यहाँ पे ओम्स लॉ ओबे नहीं हो रहा है, राइट। तो दिस इज द all were the basics of the Ohm's law and electric current. Thank you.